Hello and welcome to the TechGig podcast. I'm Sukriti Advanshi, and today we are here to talk about various career prospects in backend engineering. A backend developer is someone who builds and maintains the technology needed to power the components which enable the user facing side of the website to exist. Their backend code adds utility to everything the front end developer creates. These developers are responsible for creating, maintaining, testing, and debugging the entire backend. It includes the core application, logic, databases, data and application integration, API, and other backend processing. So, no matter what you're building, having a strong foundation is crucial, and that's where the backend engineers come in. Looking at the current demands of the backend developers, it's always good to broaden your horizon and have a better understanding of what the market is requiring. To provide you with the details of career opportunities, today I'm in conversation with Kushan Shah, who is the principal architect at Fynd. Kushan started out as a platform engineer building the early versions of the Fynd backend, scaled up the infrastructure. He currently looks after the omni-channel order management platform for both Fynd and Geomart. Welcome to the show, Kushan.
Thank you so much for having me. Pleasure to be here.
Thanks, Kushan, and I'm looking forward to some great insights from this conversation. So, quickly jumping on to setting up the pretext of what we're going to define here in the conversation today. Tell me, how would you define the platform engineering role and what do they do, and why is it so important in today's evolving space?
Sure. I think you pretty much captured the gist really well, right? So, whenever we want to build a business, let's say I want to build, I have some products to sell and I want to start selling online. And I want to build my own e-commerce website, for example, right? Uh, the the role of a backend engineer comes into picture when we want to support the features that you're building out on the front end. For example, if you were to browse through or try shopping on any of the e-commerce websites, you would have a sign up page, you would have your product details being displayed over there, you would have a search feature, you would have a cart, and then you might be paying via some payment gateway, right? So a backend engineer pretty much, as you rightly said, lays the foundation of all of this with regards to the overall architecture, with regards to the overall APIs, and I'll cover what APIs are in a few minutes. So this entire user experience that is powered on the front end has to be supported by certain data that has to come from a remote server, right? It could be the data could be as simple as showing you the user their username and their details. The data could be something like showing the product information on a product display page, or it could be something as complex as showing recommendations on whenever a user tries to add something to the cart. So a backend engineer pretty much is someone who is in charge of implementing these interfaces between the front end and the servers. We cannot directly expose the servers as is to these users, so we have to build very secure applications that are able to exchange data over the network, and this is where this is what we call as APIs, application programming interfaces. So once this is done, right, this has to be deployed somewhere on a cloud infrastructure that can then be served to the public internet, and that pretty much all of this entire life cycle of writing an API, implementing the right interfaces between the front end and the services that we write, also deploying this to a cloud infrastructure where it can be consumed by millions of users. All of this is pretty much done by the backend engineer.
All right. So, what are the tools in the tech stack that is popularly used by the platform engineers, and how can one get into this role as a fresher as plus as a lateral experienced ones?
Sure, that's a great question. So, extending the same example that I mentioned, right? Imagine if I were to build a platform or a system on which I want to start selling online. All right, I might have to build a service which is able to get me information about products. I might have to build a service I can type a keyword and it will result into the relevant results on the back end. I would have to build a login feature on which users can log in, and then I can get their login information across the system. I might have to build an integration with a payment gateway on which through which a user can pay. So pretty much the tools and the tech stack varies company to company. What I might say might not be directly applicable on for every org, because every org has a certain set of rules by which the tech stack is selected. Pretty much the broad categories of tools that are used are: there is a language on which the actual programming is done and where the APIs are written. The language could be an example of a high level language could be Python. It could be Java, it could be JavaScript, it could be something like Node.js, Golang, it could be PHP. So pretty much these are the languages, or it is a representative set of languages that are used across the board. Now the language can only help you implement the code base, but the data still has to be stored somewhere, and that is where a database comes into picture. So pretty much the popular databases that I use across the board, the MySQL is the most one of the most popular ones out there. There is Postgres. MySQL, Postgres pretty much are the stalwarts of the database ecosystem. MongoDB is also a very popular choice in the recent years. So pretty much these are uh, databases that are used across the board. Now, these databases, while they're really good at storing data and keeping it safe at scale, you might still want some data to be accessed very quickly. For example, if a user is typing something on the search bar, the user might want to see results very, very quickly. And that is where the concept of caching comes into play. So frequently access information such as search results, frequently access information such as things like recommendations across a broad set of users. We need to store it in a caching system which can store these results in memory. Uh, the popular caching systems that are used across the board are Redis is one of the most popular ones out there. There are teams which use other caches as well, pretty much depending on the use case. Now, the language in the database form the bulk of the architecture, but nevertheless, until and unless we're able to stitch it and uh, allow this architecture to be broadly opened up to end users, we cannot really get this product up and running. So, which means that if a developer is writing code on their laptop or on their personal computer, this code has to be deployed somewhere. It has to be executed somewhere. As well, right? So for us to deploy a code, we need to kind of store that code in a repository, and popular cloud repositories that are used are GitHub, which is again one of the most popular ones across the board. There's GitLab as well. There are other providers as well who give hosted repositories on which code can be stored. The reason why the storage of code is important is that first of all, multiple team members can collaborate on the same code base. So this is similar to for example, if I were to write a document which has to be reviewed by someone, I have to put it in a place where it is shareable. So for example, I might put the document in Google Docs. Similarly, the code also has to be reviewed by other people. Other people have to contribute to that code. The people have to improve and extend upon that code base. That is where the concept of having a repository which is able to allow access to multiple sets of teams is really important. So GitHub, GitLab pretty much are the broadly used environments for storing this code base. The other reason why I mentioned the code base storage becomes very important is that the deployment, or when I say deployment, the process of packaging this code and shipping it out to a remote server where it can be executed without any human intervention is where the concept of deployment comes in. So this usually denoted by a standard process called a continuous integration or a continuous deployment framework. In that, what happens is the code gets packaged into a certain format. There are a set of test cases that run upon that code, and then that code, after it passing all the sets of test cases, is then and in order to host that code, there are multiple frameworks and deployment techniques that are used. Docker and Kubernetes are, the most popular way right now to package and deploy code and host it in a way. And so that pretty much, sums up the standard tooling and the tech stack that is used out there. Now, as and when the product matures, as and when the architecture matures, we need to add additional tooling in terms of this tech stack to ensure that the the amount of traffic that this architecture can sustain is kind of instrumented. So there are sets of monitoring tools like Neuralink, Prometheus, Grafana, which help us instrument certain metrics and criteria for that code base and tell us how it is working online in the real world. So to sum up, we have a language, we have a databases. You could have a relational database, or you could have a cache. Pretty much both play their own roles. We have a code base, a repository that is used to store the code, and we then have a set of deployment tools like Kubernetes and Docker, which are used to execute this code in certain cloud environments. So that is pretty much the tech stack that is popularly used by backend engineers across the board. And this tech stack pretty much varies company to company depending on the familiarity, depending on the talent pool, depending on the overall expertise of the team with that particular tech stack. These pretty much dictate the choices at turn. Yeah.
Fantastic. Kushan, also, I would like to understand that, as developers gain these experiences, what do they need to learn to be successful in this role? Any tips that you would want to suggest?
Sure, I think that's a great question, right? So before I go to the area where you can be successful, let us try to understand how can someone get into this role as well. One of the ways to get into this role, at least the most traditional way, is to learn computer science in college, get your fundamentals right, understand data structures, algorithms. The reason why these are important is that as and when a product scales, the expectation is that the code that we write has to be really performant. When I say performant, it has to be really fast because users don't like seeing slow products. To give you an example, imagine if I type something on WhatsApp and it just takes a minute to go somewhere to the other user, you might really not get stickiness of the product, right? So the expectation from backend engineers is always that if front end has to be slick and fast, backend engineers have to really write very performant APIs. In fact, there was a study by Amazon by the performance engineering team, wherein they mentioned that for every 100 milliseconds of delay on the page load, the overall bounce rate of the users for that page is increasing. So which means that for a shopping website, if I am writing code that is slowing down or slowing down the page load time of that website, my users are not going to stick around for a longer period of time. So writing fast code is pretty much the only way to do it, and which means that we have to get our fundamentals right via the computer science education that we get. And this education is not just limited to college. Pretty much there are we could be a self-learned engineer as well. It really doesn't matter that you take computer science in college and then only that is the only way to land into this role. You could pretty much pick it up on your own. There are tons of resources out there that allow us to quickly cover the gap in terms of computer science fundamentals. Picking up a language that I mentioned, either Python, Java, JavaScript, it could be Golang. Any of these languages help us. So one way to kind of quickly get yourself ready for the industry is that get your fundamentals right, learn a language that helps you become productive, that helps you write the base amount of code for a backend, for a website to be built, or that was just an example, for a backend to be built, and learn a database, at least how to query, how to insert data on a platform. So these three things are pretty much the bread and butter. And on top of this, you could learn high-level frameworks which allow you to write APIs, high-level libraries that allow you to kind of reuse existing functionality out of the box, and really reinvent everything from scratch. So as and when you mature, all of these use cases will come into play. And if an engineer has to be productive, you need to have a very good overview of the ecosystem within that tech stack, which really helps. So as a fresher, the earlier you learn all of this, the earlier you get a fundamental side, it allows you to get an edge over others, and you are able to get into this role quickly. And then the on-the-job training, on-the-job experience in terms of real-world uh, product building would get you quickly ramped up on this backend engineering path. Laterally, there are other ways to go about come into this role laterally as well. For example, if you are a front end engineer who is capable of writing code to build the user interface for a product, or for a mobile app, or for a website, you pretty much know, and you are already consuming APIs that are written by other team members out there, right? So one way to get and kind of understand what a backend engineer does is to kind of go into these APIs, and then also try to understand how these are built, and also how they are built and hosted. So that pretty much gives you that right understanding of what a backend engineer does, and then you could start contributing to that APIs going forward. You could start building, or at least instead of the backend engineer changing an API for you, you could go around and contribute and change that API as well. So that's one way of making a lateral jump from the front end engineering side of things to the back end engineering side of things. For example, if you are a SDET, or someone who is capable and really much expert in testing out uh, features, or testing out APIs, you could pretty much you're pretty much approaching that test from an overall feature level, as a pretty much as a black box in some cases, right? And if you are interested in pursuing a backend engineering career from a SDET or from a QA to a backend engineer, you pretty much then can go deeper into how those APIs are built, what's the tech stack like, how does data travel between one system to another, if it were a distributed system, and that pretty much gives you an understanding of how things are built, and then you could start contributing into those sets of features going forward as well. So these are there are multiple ways to move laterally, and pretty much it's a it's I would not say it's that difficult to move laterally. It's just that you need to get an understanding of the base tech stack, which allows you to become productive in the long run and start contributing as well. As in when you become, or at least start out in this role in as a backend engineer, right? The career path pretty much you can follow is very, very broad in nature. So to give you an example, if you're writing, as if I were to continue the earlier example as well, right? So if imagine I build a minimum viable product of an e-commerce website as a backend engineer. What happens is that as and when I start running a business on this platform, that platform is going to experience more number of orders. There are more number of users who are going to use this platform. So one way to become successful in this role is to simply become curious about the end user needs, right? Because a product in the initial run is built out by a certain amount of hypothesis, a certain amount of uh, like assumptions around what that product would be from the user point of view. As a backend engineer, because you are maybe 2 to 3 degrees separated from the end user, having an understanding of the user's needs, having an understanding of the user's pain points allows you to structure your flows better, and then ensure that your code doesn't have a short life, for example, right? So a quick example of that would be that if users are finding it hard to search for products, and they have to just uh, visit so many pages to consume information, you could really organize that information better via better filters on the product on the website, right? So, and that requires a certain amount of architecture to be changed to introduce new components into the tech stack. So that having an understanding of the user's needs is extremely important, especially as you are the front end engineers are more exposed to the user than the back end ones. So bridging that gap really becomes important. Also, what is important is to have a broader overview of the components used across the board. For example, and this allows you to quickly pick up new things as and when required, right? So the example that I mentioned is that if you were to introduce filters on your website, the users might be able to at least filter out and quickly discover products that they like. Now, introducing a filter is something that requires a new component, which is called the search server, that is to be introduced into this architecture, right? And search server, you could use Elasticsearch, you could use Solr. So as an engineer, right, if you don't know what Solr is as an engineer, if you don't know what Elasticsearch is, when the use case comes up, you need to at least discover it, do a POC, and then start integrating it with your end architecture. So uh, one way to become successful is to know broadly what components are used across the board. There are a finite set of components used by pretty much all the standard companies out there. So once you know what is used and for what use case it is good, I think that allows you to pick the right things that can meet the needs of the business. The other way to become successful is that as and when a business is maturing on a given platform, what happens is that you start seeing more and more scale on the architecture that you build, right? And this scale requires you to radically uh, write very performant code, perform a certain amount of testing so that the traffic can be handled. To give you an example, right, companies like Hotstar, companies like Netflix pretty much see massive amount of volume during their peak times. For Hotstar, it could be IPL as an example. For somebody else, it could be something. A simple example for IRCTC could be the Tatkal window, right? So backend engineers pretty much need to be prepared for this, at least prepare the architecture for this traffic to come. And this means that you need to really understand each and every component that is used in the tech stack, along with when it can break and what are its limitations. So I think broadly speaking, to summarize, having an understanding of the customer's needs and pain points, uh, uh, going broadly into what is the universe of components used out there across other companies, and then going deep into these components and understanding where they are a good fit and where they are not a good fit. I think pretty much these three things combined allow you to become a T-shaped engineer. When I say a T-shaped engineer, you have the breadth of components, you have the breadth of qualities that are required to become successful, and then you have depth across a certain area of that tech stack on that platform. So,
Thanks for that, Kushan. I think that was really helpful for our audience. Moving on to the next one. How does this role evolve as company and team matures? I mean, from individual contributor track to a leadership track, how is the entire evolution?
sure. I think the role evolution pretty much depends on the org as well as on the product. So the right place to be would obviously be for someone to start in an org that is either in its very early stage, so that you get the experience as the product matures and you get to see the full life cycle. But having said that, right, if a developer was building an architecture for an e-commerce website, as and when for example, if I as a developer I build a certain section of that platform. For example, I only built the sign up and the login flow, hypothetically, and I am starting my career as the company is also building out their that part of the business. Now that sign up or login flow might just be very simple. It might require just a couple of APIs, and then quickly we could begin things and get things started. Now, as and when the product is maturing, right, that feature set could, or product feature could become more and more complex with time. A simple example could be if I had to build, my initial login flow would be just the user entering their username and password and then simply logging in. But then, as and when the business is expanding, I need to acquire more users, I need to connect to other areas, other channels of traffic. I pretty much need to at least make that sign up and login flow more and more seamless. For example, I could have to support it on mobile, I could have to support it on desktop, I could have to integrate with other social channels like Google login, uh, LinkedIn, etc. So whatever that engineer wrote was very simple in the initial run. could quickly become more and more complex with time. And this complexity increases, the increase in this complexity rather, pretty much you require to rethink the way that code base is completely architected and how that API is built. So while the UX has to be very simple for the user, the APIs also have to be very, very simple for the front end to consume, right? And this requires a different line of thinking in the way the architecture is built and matured. So what happens is that as and when this product matures, as and when use cases become more complex, uh, uh, the the role of an engineer, uh, at least the scope of the role of an engineer, which could just be writing a simple API, writing a couple of APIs, and now you are pretty much supporting or building an entire authentication system altogether, which has multiple insights of integrations, which has a set of layers of formations and things like that. Right. So that developer who initially started out as an individual contributor owning just a small feature now is owning a complete system altogether. And if this system is sufficiently complex, this role can really not be done by a single person going forward, especially as expectations on that product are also increasing, right? So now you have a pretty much, a product which has scaled, a system which you built has also scaled, and now there is a team required to support that. Now there are pretty much two tracks that are available out there. You could either continue increasing your scope of work from probably building out that initial system, scaling it out, adding more and more features. And one track could be an individual contributor track where you keep on shipping code for for products for these sets of features. You could start increasing your scope probably from writing the authentication system, writing the that authorization system, to probably supporting other sets of features expected on the same platform. It could be search, it could be probably cart or something of that sort. So either you kind of stay on the IC track, you keep on increasing your and widening your scope in terms of an as an engineer by uh, you know by handling more and more complex features going forward. The other track would be that while that while that area or the product surface that you're covering, if that is supported by a complete team altogether, pretty much there needs to be someone to set the standards of excellence. There needs to be someone who needs to unblock other engineers writing code on the same platform. There needs to be someone who sets the standards of how collaboration is done, how a code base should be shipped. All of these are expectations from the leadership track, where you quickly either transition from just taking care of your work to helping out others and then mentoring others in the long run. So, as and when a company grows, as and when an engineering org grows, these two tracks are kind of laid out in front of everyone, and we could then pretty much stay on the IC track, keep on increasing the scope and complexity of the contributions, or you could start helping out, unblocking others, and then start working on the leadership track. Both of these are pretty much very, very high impact career tracks overall. If you are interested on the technical side of things, if you like tinkering around with code and writing complex pieces of code, you can pretty much stay on the IC track and continue growing your impact. And you also have to realize that all of the products that you build are less about the technology and more about the people, right? So if working with people is a passion, if working with other engineers, helping out other people is a passion, then pretty much that leadership track allows you to go forward and make an impact in your career.
Okay. Now the last one, Kushan, since we've spoken about Kubernetes and energy gain and other things, tell me, why does knowledge of cloud infrastructure is helpful in this role?
Sure. So you know any any code that we write, right? It it seems very simple because we just have to write a code on a laptop and it just starts working. But that's not the reality when we have to build a product that has to be used by thousands or probably millions of users. That code has to live in a 24/7 environment uh, on servers that either we personally do not own. Uh, there are companies that specialize in this. The larger and the most popular ones being Amazon Web Services, Google Cloud, Microsoft Azure. So these companies have pretty much abstracted or built a very simple way for thousands and millions of developers out there to start hosting code and pretty much build a product by their own. So they allow everyone to rent servers by the hour. These could be compute servers. These could be database servers. This could be the physical network that connects all of these pieces. This could be caches. And the beauty of this is right that if I were to procure a server, host it in an environment, connect it to a very complex network, and then make it available 24/7 online, this is immense amount of effort that no company wants to go into and focus on the business that is really the bread and butter of our company runs. So this cloud infrastructure is pretty much something that allows you to completely be decoupled from this and focus on the product. In terms of AWS, GCP, or Azure, these are standard ways, or at least standard cloud providers that are used across the board. And the reason why they are important is because first of all, they made it very simple for us to host our code online. The other brilliant thing that these cloud providers do is that they ensure that the capacity that is allocated to us is elastic. And when I say elastic, it means that if I am supporting 1,000 users on my website, on my platform right now, if for some reason I run a sale and I need to quickly scale up my server capacity to support maybe tens of thousands of users, I can quickly do it with the help of just one button. And that elasticity is something that is really a very powerful feature of the cloud that allows companies like Netflix, companies like YouTube to quickly ramp up their infrastructure as and when required. So and the people, or at least the engineering teams who are in charge of this, the engineering teams who kind of work on this cloud infrastructure overall, are the backend engineers themselves. So you as an engineer pretty much have to understand the various options that a cloud provider gives: compute, database, cache, network. There are so many nuances, so many product options to choose from, and then kind of how do you imagine if these were Lego blocks on which I was building an architecture? You kind of need to know how to connect these Lego blocks in the right way so that they function well together, so that whenever you see scale in terms of users, whenever you see scale in terms of traffic, that Lego block has to be from it being a very simple uh, architecture, it has to become more complex and evolve over time. And then this can only happen if you know your fundamentals right, if you know the cloud infrastructure tooling right, and if you have the right DevOps knowledge to kind of take it forward in the long term. Interestingly, that's also one of the areas where a backend engineer can grow. So while you could start out by writing APIs, like supporting complex microservices, having a knowledge of cloud, having a knowledge of DevOps practices allows you to write scalable code that can meet the needs of the business in the long run. So I would say cloud infrastructure is not just a skill that is expected of you as the role evolves, but it is a cornerstone of a skill that can allow you to become, or at least grow very quickly in terms of an engineer. Because the moment you have that knowledge of the cloud and how those pieces fit in, uh, your approach, or at least your way of writing code, would completely change. So I would say cloud infrastructure is not just a skill; it could become in the long run as well. But for every platform engineer, once you gain sufficient years of experience in terms of building products from scratch, this is a very, very must-have skill that you need to master for a long-term success in your career.
Fantastic, Kushan. Thank you for this enriching conversation. I mean, the insights that you've shared for our audience today, I'm certain that this is going to help everyone. So thank you for sharing them, Kushan.
Thank you so much for having me. It was a pleasure.
Audience, hope you enjoyed the conversation. Please ensure to take a note of all the facts and insight our guest speaker has just shared. I will see you in the next episode of Decade Podcast. Till then, stay safe and keep learning.